Hello! In today's tutorial I will show you how to make a cabinet which is controlled from global variables inside an assembly. To make this, first we need an assembly, and we need to save this assembly if we want to edit the parts directly in this assembly. Then it's good also to add our parts inside. They can be empty. As you can see in my assembly, I have two parts, which are the back and the leg. The leg I won't change. The back I have created because of the finishes. I will show you how to change it to fit the sizes later in the tutorial. So after we have our assembly with parts inside, we should write some global variables. To go there, you should either right-click and manage equations, or tools, equations. If you don't have any equations or any global variables, they won't be visible here. Now when we look on this screen, I have choose the short names for the global variables because it's easier to control when you have them in equation. And in the comment section I have written a comment what this global variable mean. So we have the cabinet width, height and depth, which we should define. Then we have the leg height, which is also defined. In my case this is 20. Then we have the top width and depth, which are calculated based on the cabinet. In my case, top will be above the sides. That's why the top width and depth are equal to the sizes up here. But if you want it the other way around, you should divide the thickness of the sides. Then we have the top thickness, which we have to define. After that we have the same for the bottom. In my case, as you can see, they're also above the sides. And the bottom thickness, which we can define a separate value. Then we have the side depth, which is equal to our cabinet depth, but we can make it different. We can make the sides shorter, for example. The side height, which is calculated, it's the cabinet height without the top, bottom and leg heights. Then we have the side thickness, which we define by ourselves. Then we have the back width and height, which are calculated. Of course, you can choose different values here. Then we have the shelf width, it's calculated. The shelf depth is also calculated. There is one more variable here, which is shelf count. So if you have a higher cabinet, you would like to have more shelves. Later I will show you how, when you change this, also in the assembly itself, the shelf count will change. Of course, when we have a different count, and not only when we have a different count to define the drills for the shelf positioning, we need the shelf position, which is in this case calculated. As you can see, I have two equations. These two equations are inside our linear pattern shelves. Now we go there. As I said, you will need more shelves sometimes. So I have added a linear pattern, not to draw any sketches. I have said that direction is to the top plane, but you can change the direction. The distance between the shelves is equal to the shelf position, and the count is equal to shelf count. With these settings, when we change the shelf count, it will populate also in our cabinet. So first we start with the shelf top. I right click on the shelf top, edit part. It's warning me that this part is not fixed in space, but it's not a problem. Then I just pick some of the planes. I will pick the top plane. Then draw a sketch and add sizes. first size is our top width, so we give equal, go here to assembly, show the equations, and what we want to do now is to have it equal to the top width, and then click OK. The next size is the top depth. Then we give again equal, go to the assembly and choose the top depth for this part. Then we go to features, extrude boss base. As a start, you just hit OK, and then you double click it, double click on this size and choose the top thickness. Now we rebuild, and you can see our top is taking the values we have defined. Now this is the top. Then we go to the bottom and perform the same steps, but this time we took the sizes for the bottom. Now we rebuild. I would like to save what I have done to my PC. Okay, here I have some errors. I'm going to check my equations again. I don't know what this error is for here. I don't see it in the equations itself. Now we go to the site. On the site, I would like to add the sketch on the right plane. So we take first the site width. Or actually depth. Then we take the side height, and of course at the end we fix the side thickness. Because the site is the same, you can see now that both sides are building at the same time. So we have our bottom, we have our sides, we have our top. Now we're going to build the shelf. Oops, wrong. I took the wrong variable, but you can always correct it. So again, I will save everything. Now what is left is our back. I think I totally mistaken the shelf sizes, so I will correct them. Okay, I have to edit the sketch. Yes, I took the side instead of the shelf sizes. Okay, the shelf width is correct. And this is the side thickness, not the shelf thickness. Oh, but I have not defined the shelf thickness. So, okay, we're missing the shelf thickness. Now we go back to equations and add a new one, which is for the shelf thickness. Then we go back to our shelf. And correct with the right size here. So now our smart parts are ready. We have to position them correctly. And we'll start with the bottom part, which will go to the origin. Then one side, then we have our bag. It will be a little bit different mating. You can use this style of mating also if you don't want your sides and the top bottom to be flat. And now it's time to position the shelf. The shelf is a bit smaller. That's why I will use also this mating here. And now to have it for easier mating, I will make a small change to the shelf. I will edit this boss extrude so it's mid-plane. And now I will mate the shelf top to the bottom with a distance which is equal to our equation here. Okay. Let's show the equations. I'm not able to put the equation. Let's try it. In another way. So first we put these equations, then when you double click on the distance you will have the size. Once you have the size, you can choose the global variable which is controlling it. It's the same with features. That's why we were first making the boss extrude and then changing the size. Now it will be controlled from this global variable. Again, we save everything. And now I will add a sketch to position the legs. So I will add it to the top plane. I will use offset from the edges, which is 35. The size of my leg is 60. I want it on some distance, so I make it 35. Then we put 4 points. And position them on the 4 corners. I will rename the sketch legs. Then we have to adjust one of our legs in the correct position. As I said, this is on distance 5 in my case from the edges. Legs position. And now we add a sketch driven pattern. We choose this sketch, we choose this leg. By default, it's aligning the origin of the leg to the point, but we don't want to do this. We want based on selected point and choose the one on which our leg is sitting, and then just give it OK. We can hide the leg position and now add here that this is our legs. And as you can see, our cabinet is ready. Now when you go to the equations, I will move them here so you can see better and change the sizes. This will automatically change the size of our components in the cabinet, and they will be adjusted. So for some It's not calculating exactly correctly. And you should go out like for the shelves, because you have external calculation, but as you can see, the shelves are exactly positioned and the cabinet is changing based on our sizes. So this was the first part of this tutorial. In the next tutorial I will show how to adjust also the cuts and the drills on the different components. If you enjoyed the video and find it helpful, don't forget to like it. And if you want more such content, subscribe for the channel.